Hello guys, welcome back to my YouTube channel. I am back with another video of data science. In this video, we are going to learn about data preparation phase to model the data. We will cover a range of topics from data partitioning and balancing to building decision trees and forests. By the end, you will be confidently prepare your data for machine learning projects. Okay, so first let's start with data partitioning in Python. Why do we need to partition the data? Data partitioning is crucial for building robust machine learning models. It allows us to evaluate the performance of our models on unseen data, ensuring they generalize well to new inputs. We need to partition the data into train, test, and validation. We typically split into three sets, which is training to train the model, testing to evaluate its performance, and validation for fine-tuning hyperparameters. The ratio depends on the dataset size and the complexity of the model. Okay, so let's have a look at this simple example code. Okay, so now here we are using from sklearn dot model selection import train test split for splitting the dataset into training and testing, and import panda spd for creating the data frame. Okay, so this is our example dataset, feature 1, feature 2, and this is our target variable. And we are creating our data frame using pd.data frame and passing the data into it, and then we are partitioning the data into x, which are the features, and y, which is the target variable. Features are feature 1 and feature 2, so we're putting it in 1. And then we are splitting the training and testing data sets using xtrain comma xtest comma ytrain comma ytest. These are the variable names. And train test split, in train test split we pass the x and y as it is, and test size is equal to 0.3, which means 30% into testing data set and 70% into training data set. And we use random state equal to 42 so that we get the same output each time. And now we can print the partition data shapes using xtrain dot xshape and xtest dot shape, ytrain dot shape, and ytest dot shape. Let's copy paste this code into a Jupyter notebook. Okay, now you can see that this is the example data set, and here we are creating a data frame and then partitioning data into x and y, where x are the features and y is the target variable. And then we are splitting our data set into training and testing, and training is 70% and testing is 30%. We pass testing size equal to 0.3, and then we are printing the values of shape. Now let's see the output. Okay, now you can see that explain shape 7 comma 2, express shape 3 comma 2, and similarly this. Now let's move forward. Okay, now we need to balance training data. So what is the need for balancing the data set? Imbalanced data set can lead to biased models that favor the majority class. Balancing techniques aim to equalize the representation of classes, leading to fairer and more accurate predictions. Oversampling duplicates minority class samples to increase its representation. Techniques include SMOT, and undersampling removes majority class samples to reduce its dominance. टेक्निक्स इंक्लूड रैंडम अंडरसैम्पलिंग एंड क्लस्टर बेस्ड अंडरसैम्पलिंग. सीधा सीधा मतलब ये है कि जो अपना इम्बैलेंस डेटा सेट है उसमें एक तो माइनॉरिटी क्लास होगी, तो या तो अपन एक चीज कर सकते हैं कि माइनॉरिटी क्लास के सैंपल को डुप्लीकेट कर दें इससे कि वो इंक्रीज हो जाए, डेटा सेट बैलेंस हो जाए. ये एक मेजोरिटी क्लास होगी जिसके अपन सैंपल्स रिमूव करके उसको कम कर सकते हैं, तो जिससे कि डेटा सेट बैलेंस हो जाए. नाउ लेट्स लुक एट दी सैंपल कोड. Here we are using from imblearn.oversampling import smooth sample and balance data. This is our sample data, and again we are distributing in x and y, and x includes feature and y includes target variable. So here we are applying smooth. Okay, so this creates a smooth instance, and we pass the random state equal to 42, so we get the same output every time. And then what we are doing is we are mm, resampling. So x resampled comma y resampled is equal to smooth dot fit resample x comma y. So this will resample the data and balance the data set. So print original data set, x.shape, y.shape, and printing the resample data set, x resample.shape and y resample.shape. So let's copy and paste it in our Jupyter notebook. Here is our Jupyter notebook. Let's try to copy and paste it. Okay, now you can see that this is our data frame. And so now we are applying this mode to resample the data using SMOTE, random state 42 for so that we get the same output each time. And then we are printing the shape. Now let's run it. तो एक एरर आ रही थी कोड में क्योंकि fewer samples थे तो उसको मैंने फिक्स कर दिया है by setting the k neighbors equal to 2. Now it's running completely fine. Now let's move back to our presentation. Okay, now let's build the decision trees using part algorithm. Classification and regression trees is a popular decision tree algorithm used for both classification and regression tasks. It recursively splits the data based on features to create a tree-like structure. It uses Gini impurity to measure the heterogeneity of data at each node. It aims to minimize impurity by splitting the data into subsets with homogeneous classes. Let's look at the sample code. We are using pandas, importing pandas SPD, and then skill and word model selection, import train text split to split the data into test and training sets. Then from skill and word tree, import decision tree classifier, from plot tree to plot the decision tree, and skill and word matrix, import accuracy score to evaluate. Now this is our sample data set, age, income, credit score, and default, which is target variable, and these are the features. And now we will create a data frame using data frame, and we will divide the variables into x and y, where x contain the features and y will contain the target variable. Then we will perform train text split to split the data set into training set and data testing set, where testing set is equal to 0.3. And now we will build the decision tree using decision tree classifier, where we pass the criterion equal to Gini, maximum depth equal to 3, and random set equal to 42, so that we get the same output every time. And we will train the model using clf.fit and pass the xtrain, ytrain variables. And we will visualize the data tree using plt.figure size and plot tree. Now let's copy and paste it in our Jupyter notebook. Okay, now you can see we have got the output. There's a card decision tree. Uh, Gini index is 0.48, then 0.0. This is the desired output. So now let's see C 5.0 decision tree. C 5.0 algorithm is an enhancement of the earlier algorithms. It uses similar recursive splitting approach, but introduces optimizations for handling missing values and pruning the tree. It uses information gain as the splitting criterion. It measures the reduction in entropy after splitting the dataset based on a feature. Okay, तो इसका कोड बिल्कुल सेम टू सेम वैसा ही है, बस यहाँ पे डिसीजन ट्री क्लासीफायर में अपन क्राइटेरियन इक्वल टू गिनी की जगह एंट्रोपी पास कर देंगे, बाकी पूरा सेम है सब कुछ. तो लेट्स ट्राई टू रन इट इन जुपिटर नोटबुक. So this is our sample output using C 5.0 decision tree. Let's increase them. So in this presentation, we have explored essential data preparation techniques for machine learning, like we covered partitioning, balancing, and building decision trees. So that's it for now. See you in the next video. Thank you. Till then, keep learning and keep exploring.